these, I need to show you quickly. I'm not gonna bug you about these. They show up in a couple of your problems today. And they're basically what to do if you have a trig function with a negative angle on it, and without going into a great deal of time and effort, which I don't want to spend for something we're not going to use much this year, it'll make a whole lot more sense next year. I'm just going to flat tell you, if you have sine of a negative angle, say it's negative 30 degrees or something, you pull the negative out front, and it becomes negative sine of the positive angle. So you would have a negative sine of 30 degrees on that. Okay, cosine's the weird one, and there is a reason it does this, but I don't have the luxury of 15 minutes to go into the whole explanation, so you're all going to believe me. Cosine, when it's got a negative angle, it's the same thing as the cosine of the positive angle. You just drop the negative out of there completely and just ignore it. You don't use it. And then tangents like sine, tangent pulls its negative out front. For right now, you just have to believe me on those until we learn what even and odd functions are.
Trig doesn't believe you.
Do you want to know how to work your homework? You want me to prove that to you?
Homework.
Yeah, okay, sorry, you have to believe me. Yeah, you have a couple problems that they show up in that you're going to have to deal with it. So, now, finally, woo, doggies, we get to work the actual problem. Okay, why does anybody want identities?
To know who you are.
Not that kind of an identity, but kind of, sort of. Okay, identities let us take these complicated, messy trig expressions, equations, and we can use identities on them and turn this complicated, messy thing down into something simple that we can work with. And so we use those identities to take messy and make it simple. Okay, now you're probably going, well, that's not very messy, but I'm starting out nice. Okay, and you all have an identity sheet in front of you. Okay, so the instructions are going to say here is they're going to say, change this problem to sines and cosines and simplify. Okay, so I want to know, what could I change cosecant into? First question, could you use identities 6, 7, and 8, the reciprocal identities on this?
No.
Why?
Because there's no square.
There's no squares. So you can't even look at 6, 7, and 8. Okay, I am telling you something we do typically with these kind of problems is if you're ever in doubt and you don't know what to do, always the best thing to do is go change everything into a sine or a cosine. Get them into something, sine and cosine are in common to all the other functions. So, looking on your sheet, what's something we can change cosecant into? Using identity number 1. Cosecant is 1 over the sine of x. Okay, tangent, you will see you have 2 choices of it on there. 3 and 4 are both identities for tangent. Which one's the smart one in this instance?
Number 4.
4 you will use way more than you will ever use 3. Because 4 changes it into sine and cosine, and that's huge for us. So if I change that into sine x over cosine x, now what miracle mathematics happens? Yes, it's good old rational functions and cross-canceling. Goodbye sines. What's left? Okay, with 1 over cosine, which I would actually consider that a simplified answer, but you can go one step farther, Jake. What can I do with 1 over cosine? Look at your identity sheet because you just missed this whole problem.
You can make it number 2.
Yes, number 2, you can change 1 over cosine into secant. So you just changed that 2 trig functions multiplied down to 1. You made it simpler, easier to work with. Okay, so let us try several more. All right, this one, here's an example. They gave you a tangent with a negative angle in it. You do not want negative angles. What are you going to do about it? Yeah, we said the rule says on tangent you can just pull the negative out front. So yes, do that, get that out of your way. So it's just going to have a negative sitting there on this whole problem. Okay, now, what can you change tangent into? Okay, and once again, you want to use number 4 most of the time. Unless the only time 3 is good, you use 3 if you have lots of tangents and cotangents in your problem together. Otherwise, you hardly ever use 3. So I would agree. She said change tangent into sine over cosine. What can I change secant into? That's number 2. Secant is 1 over the cosine of angle theta. Then, oh no, what do you do when you have a fraction divided by a fraction? Yeah, we multiply by the reciprocal. And once again, magic happens. If I flip that over and multiply, golly gee, what cancels? The cosines cancel. And, well, that's not a negative. Sorry, I shouldn't have written what negative there. I got negative happy. So what's left? A negative sine of theta. Ta-da! You have simplified it. Okay. Allow me to threaten you within an inch of your life. A trig function does not exist if it does not have an angle attached. You will write a variable there. I don't care if you write thetas or x's, but you have a variable with your trig functions. You cannot, doesn't mean anything if it doesn't have an angle. So, I don't care, thetas, x's, they're going to use all kinds of different Greek letters on you. Just make sure you use something and be consistent. Oh, very good. Oh, I got to remember that one, DJ. Sine without a variable is just a sin.
It's a sin to have a sign without a variable.
I like that. I got to remember that. All right. This one tends to stall us a little bit. All right. So, this one, when you look at one and you see lots of terms squared, pluses or minus in between the terms, which identities do you think you should start looking at? Yeah, this is where you start looking at 6, 7, and 8 going, okay. Now, obviously you have no identity on there that has 3 different trig functions in it. But do you have any identity that has 2 of those if you're looking at 6, 7, or 8?
Tan and secant, 7.
Number 7 does have tangent and secant in it. Number 7 says 1 plus the tangent squared of x equals the secant squared of x. Okay, but we don't have that on there. But can we rearrange number 7 to say, in our case we have secant squared minus tangent squared. Can I rearrange number 7 to say secant squared minus tangent squared? I can move tangent to the other side, can't I? So if I move the tangent squared to the other side, I would have secant squared x minus tangent squared x. And what is it left to be equal to? 1. Just the 1 is over there.
So we put 1 in.
So yeah, you are literally taking out that whole chunk, and it just became 1. And now you have a minus cosine squared left. Well, that might be simple. Or, anytime you see 1s with sine squared and cosine squared, you better be checking out number 6. That's number 7. Okay, so we check out number 6. Number 6 normally says sine squared of an angle plus cosine squared of the angle is equal to 1. Okay, is there any way I can get that rearranged to be 1 minus cosine squared?
Yeah, just minus cosine.
Yeah, if I move cosine to the other side, wouldn't I have 1 minus cosine squared? So sine squared stays here, and I'm just subtracting cosine squared over to the other side. And so, since 1 minus cosine squared, it says equals sine squared of the angle, that whole expression is now equal to sine squared x. And ta-da, you took that 3-term expression down to 1 again. Makes it easier to work with. Now, right now we're just learning to simplify. Eventually then you use it to solve problems with. We will not solve this year. No, there's a whole lot of building blocks we need to build in between there yet. So you're going, those are too easy, Mrs. Meyer. Why don't you challenge us? I can hear it. They're screaming, yes, challenge me. All right. Let's see what we can do with this one. I'm giving you the cosine of x over the sine of x plus, do I want to know what's going on?
I do.
Okay. So, you'll notice this problem. What do you see in this problem? sines and cosines. Okay, none of them are squared, so 6, 7, and 8 are currently out of the picture. We don't have any squares. Okay. Do you think I want to change them out of sines and cosines back into secants and cosecants? No. If you got sines and cosines, you would have stayed in sines and cosines. So, what else is there left to do if I can't change this into anything else? How it says add them. How do you add fractions? Yes. So algebra still applies. Those rational function problems you did where you had to add something with over x plus 1 plus something over 2x plus 3 and make common denominators, same thing, just trig functions. So yes, you want to make a common denominator here. So what would my common denominator be? That's the big question. Yeah. Sin x is one term, 1 plus cosine is a totally different denominator, so you've got to have one of each. So yes, you would write it as sine of x times 1 plus cosine of x. Okay. So you're going to do that common denominator for each fraction. Okay. And then you're going to go back to the basics. How do you make common denominators? You have to look at your first fraction and go, gee, what does this denominator not have? It's got a sign. It doesn't have a 1 plus cosine, so therefore I must take it times 1 plus cosine of x. But of course, if I multiply the denominator times 1 plus cosine x, I must multiply it times the numerator. And then I have to distribute it because I'm multiplying a cosine times a quantity. So I got a cosine of x plus a cosine squared x. Yes. It's all right. So you're going, this is not getting simpler. This is getting messy. But magic will happen, trust me. So now, what is the second fraction missing? It needs to be multiplied by a sine of x. Well, that's not so bad. And so if I take it times the sine of x in the numerator, what will I have? Sine times sine is indeed sine squared x. Okay. So you've made the common denominator. I now want, since I've made the common denominator, why do we make common denominators? So you can add them together. So the next step is add them together. Are there any like terms in the numerator that we can combine? No. So you're going, great. All I did is make one giant fraction mess. But still, the magic is going to happen. Any part of that, ring your bells and you're going, whoa, wait a minute. That's an identity. Hold on, let them look.
Yes. Number 6 equals 1. 6. Yeah, 6.
The one after 5 and the one before 7.
Because we're seeing the squares going, ooh, sine squared, cosine squared.
Yeah.
So yes, that whole cosine squared x plus sine squared x, that whole thing is 1. So you just turned that whole thing out of there. It just became 1. Now let me rewrite so you realize what you've got left. You have cosine of x plus 1 over the sine of x times 1 plus the cosine of x.
Which is the exact same. Cancel that out.
Okay, I can cancel what?
The cosine of x plus 1.
Yeah, you cancel whole quantities. And cosine of x plus 1 and 1 plus cosine of x, that's the same thing. Those just cancel.
So you got 1 over sine of x is equal?
So you have 1 over sine of x, which actually I would consider that an acceptable answer. However, they may go one step farther and say 1 over sine is identity number 1, it's cosecant of x. So you gotta admit that was pretty cool. Took all that mess, came out that simple. And it was fun doing it too. Well, we have one last problem solved. Oh, boogers. I suppose I should stop.